Equations in y equals mx form. Lesson 3 in Chapter 3. Essential question. Why are graphs helpful? Vocabulary, direct variation, constant of variation, constant of proportionality. Real-world link. Charity. The amount of money David can raise for the Wish Upon a Rainbow Bike-a-thon is shown in the table. Biking time is in hours, represented by X, which is 2, 4, and 6. Money raised is in dollars, that is, Y is 20, 40, and 60. Recall what the ratio of two variable quantities is constant. A proportional relationship exists. This relationship is called a direct variation. The constant ratio is called the constant of variation or constant of proportionality. To save us some time, we're going to abbreviate that. See, constant of proportionality. Complete the steps below to derive the equation for a direct variation. So in order to find that, we're going to use the slope formula of y2 minus y1 divided by x2 minus x1, which represents our slope of m. So if we were to define x1, y1 as 0, 0, and x2, y2 as just x and y, then we would rewrite our equation as y minus 0 divided by x minus 0, which equals the slope. So when you simplify, y minus 0 is y, x minus 0 is x. So y divided by x equals m. Well, now I want to get rid of the x in my denominator on the left, so I'm going to multiply both sides by that x. On the left side, that simplifies down to y. So y equals m times x, because we use the multiplication property of equality. So number 1, use the table to find the rate of change. Then write an equation in y equals mx form to represent the situation. Well, the rate of change is just going to be the slope. So I could have the ordered pairs of 220, of 440, or 660. I'm going to choose 2, 20 and 4, 40. Again, you could do 660 if you want. Then I'm going to use my slope formula of slope equals y2 minus y1 divided by x2 minus x1. I'm going to label my ordered pairs x1, y1 and x2, y2. Then I'm going to plug in my values. 40 minus 20 divided by 4 minus 2. 40 minus 20 is 20. Divided by 4 minus 2 is 2. 20 divided by 2 is 10. That is my slope. So when I go back to number 1, my rate of change is 10. So rate of change is the same thing as slope, which we solved for 10. So if I have y equals mx, I want to replace my m value with 10, because I know that m equals 10. So this becomes y equals 10x. That is an equation in y equals mx form to represent the situation. This represents that it is $10 per hour. So let's continue. Key concept is direct variation. So in words, a linear relationship is a direct variation when the ratio of y to x is a constant, which is m. We say y varies directly with x. Symbols: m equals y divided by x, or y equals mx, where m is the constant of variation and m does not equal 0. An example is y equals 3x. So this example can be graphed you go through 0, 0. Then the slope tells you go up 1, 2, 3 to the right 1, and that point hits on the graph. So y equals mx, this is off to the left. In a direct variation equation, y equals mx. M represents the constant of variation, the constant of proportionality, the slope, and the unit rate. So again, the M has many representations. So that's the slope, the constant of variation, constant proportionality, or unit rate. All the same name for that one thing. So the slope of the graph of y equals mx is m. Since 0, 0 is one solution of y equals mx, the graph of a direct variation always passes through the origin. So there are 3 requirements for direct variation. First, it must pass through the origin, which is 0, 0. Number 2, must be a straight line. And the third requirement is must have a constant of proportionality or slope. Continuing, example 1. The amount of money Robin earns while babysitting varies directly with the time as shown in the graph. Determine the amount that Robin earns per hour. Well, in order to do that, I need to find some ordered pairs. So I know that it starts at 0, 0, because if Robin doesn't babysit at all, then she doesn't wind up getting paid anything. The next time I see it hits on a cross section is right here at 2, 15. So this means that she works for 2 hours. This means if she works for 2 hours, she gets paid $15. Then the next time it hits is 4, 30, meaning if she works for 4 hours, she gets paid $30. So there are 3 ordered pairs. We have 0, 0, 2, 15, and 4, 30. Now, in order to find my constant of variation, the unit rate, which is my slope, I need to pick 2 of these ordered pairs. So I'm going to pick the first 2. You could have picked the first one and the third one, or the second and third. Doesn't matter, just whichever one you want. I'm going to use my slope formula. Slope equals y2 minus y1 divided by x2 minus x1. And I'm going to label my ordered pairs. x1, y1, x2, y2. I'm going to plug it in for my different values. 15 minus 0 divided by 2 minus 0. That leaves me with 15 divided by 2. And I can leave that as 15 divided by 2, or I can say that my slope is 750. Now the reason I'm writing it like that means that Robin earns $7.50 per hour that she babysits. So do you got it? Let's do this problem to find out. Letter A. 2 minutes after a skydiver opens his parachute, he has descended 1,900 feet. After 5 minutes, he has descended 4,750 feet. If the distance varies directly with the time, at what rate is the skydiver moving? So that means that our x and our y values, our x is going to be time, and our y is going to be distance. So I'm going to write my 2 ordered pairs. Let's see. 2 minutes after a skydiver opens his parachute, he has descended 1,900 feet. So the time is 2 minutes, and they've descended 1,900 feet. That means it's a negative direction. Then after 5 minutes, they've descended 4,750 feet. So those are my 2 values. Now I'm going to use my slope formula. Slope equals y2 minus y1 divided by x2 minus x1. Then I'm going to go in and solve for, or I'm going to label my points. I have x1, y1, then I have x2, y2. I'm going to plug my values in, so negative 4,750 minus negative 1,900 divided by 5 minus 2. So I'm going to go in, there's subtraction, so I'm going to add, make that a positive, and the denominator, I'm going to add and make that into a negative. So negative 4,750 plus 1,900 gives me negative 2,850. And I'm going to divide that by 3. That gives me negative 950. So, at what rate is the skydiver moving? It's negative 950 feet per minute. Negative 950 feet per minute. Let's continue. Example 2. A cyclist can ride 3 miles in a quarter of an hour. Assume that the distance biked in miles y varies directly with the time in hours x. This situation can be represented by y equals 12x. We're going to graph the equation. How far can the cyclist ride per hour? So we'll make a table of values, then graph the equation y equals 12x. So I'm going to make x, which is going to be represented by hours, and then we're going to have miles, which is y. And I'm going to put the equation y equals 12x to the right. So it says the cyclist can ride 3 miles in a quarter hour. So we're going to start at 0 hours, 1 hour, 2 hours, and go from there. So when I plug in my 0 into the equation, y equals 12 times 0, that means that my y value becomes 12. Then when I have my value of x being 1, it becomes y equals 12 times 1, which is 12. And I apologize, the previous one should be 0. So 0 hours, 0 miles. 1 hour, 12 miles. 2 hours, well, I do y equals 12 times 2, which is 24. If you had it for 3 hours, you would have y equals 12 times 3, which is 36 miles. So it's asking how far can the cyclist ride per hour? Well, that wants the unit rate. How many miles per 1 hour? Well, according to my graph, if I want 1 hour, that means that I have traveled 12 miles. So that means you were traveling 12 miles per hour. So we can graph these at 0.00, at 112, at 112, at 224. If your graph was big enough, you would also do 336. And then you can connect these points. So the unit rate is the slope of the line. So the cyclist can ride 12 miles per hour. So again, this represents your slope. Got it? We're going to do this problem to find out. Letter B, a grocery store sells 6 oranges for $2. Assume that the cost of the oranges varies directly with the number of oranges. This situation can be represented by y equals 1/3 x. We're going to graph the equation. What is the cost per orange? Well, just like before, I want to make a table of values. So x is going to be the number of oranges. Y is going to be the cost. And then we're going to use our equation of y equals 1/3 x. So I'm going to start with 0. So if I plug 0 in for my x, that becomes y equals 1/3 times 0, and that gives me the cost of 0. I'm going to find 2 more values. I'm actually going to use values that are factors of 3, meaning 0, 3, 6, 9, so on and so forth, because I have a fraction with a denominator of 3. If I multiply by a factor of 3, that gets rid of the denominator. So y equals 1/3 times 3. Well, 1/3 of 3 is 1. Then y equals 1/3 times 6. Well, that becomes y equals 6 divided by 3, which equals 2. So I'm going to graph these. Well, before I graph them, I need to label my x-axis and my y-axis. My x-axis is the number of oranges. The y-axis is the cost, and that's in dollars. So I'm going to plot the point 0, 0. Then I'm going to plot 3, 1. So 3, 1. So that means 3 oranges cost $1. Then I'm going to plot 6, 2. So 6 oranges cost $2. Then I'm going to connect my line. I'm going to connect my points with a line. So what this is saying is that it is 3, whoops, my apologies. What this is telling me is that it costs three oranges cost $1. But I want to know how much one orange costs. So I'm going to divide the numerator by 3. Well, if I divide the numerator by 3, I got to divide the denominator by 3. Well, 1 divided by 3 actually gives me 1/3, which is equivalent to 33 hundredths. So it costs 33 cents per orange. Let's continue. So let's compare direct variations. You can use tables, graphs, words, or equations to represent and compare proportional relationships. We have the table, we have a graph, words, and equations. So let's just stop and reflect for a moment. In a proportional relationship, how is the unit rate represented on a graph and explained below? So for here, it is represented by the slope. And as a reminder, slope is also m, which is also the rise divided by the run. So when the x value changes by an amount a, the y value will change by the corresponding amount ma. So let's try this. For an example, the distance x in miles covered by a rabbit in x hours. The distance y in miles covered by a rabbit in x hours can be represented by the equation y equals 35x. The distance covered by a grizzly bear is shown on the graph. Which animal is faster, and explain? Well, I'm going to take out some key information. So for the rabbit, we're representing it with this equation y equals 35x. So to the left side, I'm going to write down the rabbit. Y equals 35x. Well, the key piece of information in this equation is the 35. That represents my slope. I know that because this is represented by the equation y equals mx. And m happens to be 35. So that means that the rabbit is traveling 35 miles per hour. Well, now we need to find the grizzly bear. Now, the grizzly bear happens to give us ordered pairs. So if I have 1, 30 and 2, 60, I'm going to use the slope formula. Slope equals y2 minus y1 divided by x2 minus x1. I label my points x1, y1, x2, y2. And I'm going to plug those into my slope formula. So 60 minus 30 divided by 2 minus 1. That gives me a numerator of 30 divided by a denominator of 1. So that means that the grizzly bear is traveling 30 miles per hour. So if I write that over to the left, grizzly bear is at 30 miles per hour. So to answer the question, which animal is faster? Well, the rabbit's going to be faster. And that is because 35 miles per hour is greater than 30 miles per hour. You could also write it something similar to this. Since 35 is greater than 30, the rabbit is the faster animal. Got it? Let's do these problems to find out. Financial literacy. Damon's earnings for 4 weeks from a part-time job are shown in the table. Assume that his earnings vary directly with the number of hours worked. So that means that we have y for the total pay and x for the time worked. So we'll use the equation y equals mx. Well, we need to figure out what the m is. So I'm going to have the ordered pair 15 comma 112.50, and I'm also going to take the ordered pair of, let's go with 9 comma 67.50. Again, you can choose whatever values you want. There are 4 different ones to pick from. I happen to pick the smallest one of 9 comma 67.50, and then the second largest one of 15 comma 112.50. All right, so slope equals y2 minus y1 divided by x2 minus x1. Then I'm going to label my points x1, y1, x2, y2. And plug it in. 67.50 minus 112.50 divided by 9 minus 15. Well, 67.50 minus 112.50 gives me negative 45. Divided by 9 minus 15 gives me negative 6. Negative 45 divided by negative 6 equals 7.50. So that's $7.50 that Damon earns per hour. He can take a job that will pay him $7.35 per hour worked. Which job has the better pay, and explain? Damon's current job has the better pay because $7.50 is larger than $7.35. Example 4. A 3-year-old dog is often considered to be 21 in human years. Assume that the equivalent age in human years, y, varies directly with its age as a dog, x. Write and solve a direct variation equation to find the human year age of a dog that is 6 years old. So let's start by letting x represent the dog's actual age and y represent the human equivalent age. So x equals dog's age, y equals human age. So if we know that a 3-year-old dog is considered to be 21 in human years, I know x equals 3 and y equals 21. So if I have the equation y equals mx, I'm going to take my values of x, which is 3, and I'm going to plug it in for my x value, and y, which is 21, plug it in for my y value. So 21 equals m times 3. I'm going to divide both sides by 3 to get my variable m by itself. 21 divided by 3 gives me 7. 7 equals m. Well, I need to replug that into my equation. Y equals mx. This time, I'm going in and I am substituting my value of 7 in for m. So that gives me y equals 7x. So that's going to be my equation. So got it? I'm going to do these problems to find out. So a charter bus travels 210 miles in 3.5 hours. Assume the distance traveled is directly proportional to the time traveled. Write and solve a direct variation equation to find how far the bus will travel in 6 hours. So first we need to solve a direct variation equation. So if I know that it is y equals mx, y is 210, x equals 3 1/2, so I'm actually going to make that 3 5/10. I'm going to plug that into my equation. 210 goes in for y, 3 5/10 goes in for x. So 210 equals m times 3 5/10. I'm going to divide both sides by 3 5/10. And that gives me 60 equals m. So m equals 60. So I take my direct variation equation, y equals mx, and I'm going to plug 60 in for m this time. So y equals 60x. So that's the first part of my answer. Y equals 60x. Now it wants to know how far the bus will travel in 6 hours. Well, I'm going to plug in 6 for x. So y equals 60 times 6. Y equals 3,600. I'm sorry, 360 miles. That is how far the buses traveled in 6 hours. Letter E, a monarch butterfly can fly 93 miles in 15 hours. Assume the distance traveled is directly proportional to the time traveled. So that means that x is going to be hours. In this case, it's 15. And y is going to be miles, which in this case is 93. I got that information from the first sentence. So if I use the equation y equals mx, I'm going to plug my y of 93 in for y and my x in for the x. And that gives me 93 equals m times 15. I'll divide both sides by 15. 93 divided by 15 simplifies down to 6 and 2/10, which is my slope. So m equals 6 and 2/10. So if I have the equation y equals mx, I'm going to put 6 and 2/10 in for my m, and I get y equals 6 and 2/10 x. So that's my equation. Now it's asking to find how far the monarch butterfly will travel in 24 hours. Well, I know that 24 hours represents my x value. So y equals 6 and 2/10 times 24. So that gives me y equals 148 and 8/10 miles. So in a 1 day period, in 24 hours, the monarch butterfly travels 148 and 8/10 miles.